Misconception about gravity in space. The idea that there is no gravity in space is a common misconception. In reality, gravity extends throughout the universe, affecting everything from planets to stars to galaxies. What changes is the strength of gravity as you move further away from massive objects like planets or stars. For instance, Earth's gravitational pull decreases with distance, but it never becomes zero. Satellites, space stations, and even astronauts in low Earth orbit (LEO), which is only about 400 to 2,000 kilometers above the Earth, are still well within the range of Earth's gravitational influence. In fact, gravity at this altitude is about 90. Different types of orbits. Satellites can have different types of orbits depending on their altitude. Low Earth orbit (LEO). Satellites in LEO are typically 100 to 2,000 kilometers above the Earth. The International Space Station (ISS) is in this orbit. Satellites in LEO move very fast, circling Earth in about 90 minutes. Geostationary orbit (GEO). Some satellites are placed much higher, about 35,786 kilometers above the Earth. At this altitude, satellites move at a speed that matches Earth's rotation. So they appear stationary over one point on Earth. These satellites are often used for telecommunications and weather monitoring. Polar orbits. Some satellites travel from the North Pole to the South Pole in each orbit, allowing them to observe different parts of Earth as the planet rotates underneath them. These are used for mapping, spying, or environmental monitoring. Free fall and weightlessness in orbit. In space, both satellites and astronauts experience free fall, which gives the sensation of being weightless. But this doesn't mean that gravity is absent, it's just that everything is falling together. Imagine you're in an elevator that suddenly falls, though much safer in space. Inside the elevator, you'd feel weightless because both you and the elevator are falling at the same rate. This is what happens to astronauts and satellites in space. They are all falling together around the Earth, creating the sensation of weightlessness. This condition is called microgravity, where the gravitational forces are still present but appear much weaker because everything is falling at the same rate. Astronauts aboard the ISS, for example, experience microgravity because both they and the ISS are in free fall as they orbit Earth. The ISS orbits at a speed of about 28,000 kilometers per hour, 17,500 miles per hour, which allows it to stay in orbit and continuously fall around the Earth. Self-propelled motion of satellites. Satellites don't just sit still once they're in orbit, they need occasional adjustments. Spacecraft and satellites are equipped with small thrusters that use a type of propulsion to adjust their position or orientation, counteract drag from Earth's atmosphere for lower orbits, or move to different orbits when necessary. Geostationary satellites, for example, use thrusters to maintain their position over one spot on Earth. Even though they appear stationary, they are constantly moving at high speeds to keep pace with Earth's rotation. Gravity's role beyond Earth. It's important to note that gravity doesn't just influence Earth's satellites. Every celestial object, including the Moon, the planets, and even galaxies, is governed by gravity. For example, the Moon orbits Earth because of Earth's gravity. The planets orbit the Sun due to the Sun's gravity. Even entire galaxies are influenced by gravitational forces between them. Objects in space follow these orbital paths due to the gravitational forces between them, combined with the momentum from their movement.